Okay, guys, so we are wrapping up lesson 5.1 today. Bunch of stuff. This is our third day on this lesson. Okay, so what we're going to do today is solve trig equations. Okay, so we will need that unit circle eventually. Okay, so an equation is not an expression that we simplify. An equation has an equal sign, has two sides to the equation, and with our equations we will be able to solve for the variable in the equation. So we're finding theta, or we're finding x, not just simplifying. Okay, so, oh dear, if I pick up with those examples, is this 16?
Yes.
Okay, thank you. All right, so this one is still simplifying here before we get into an equation. Simplify to an expression of a single trig function. One minus sine squared x over 1 plus sine x. Simplify to an expression of a single trig function. How many trig functions do I have right now? 2, right? There's one and there's another one. So I want to somehow get this down to 1. Can I cancel the ones and can I reduce the signs? No. Okay, why? Because of these pesky little plus and minuses. So is sine a factor of the whole numerator? No. Is sine a factor of the whole denominator? No. If they were multiplied, we could cancel all day long, but they're not. Okay, so what I'm going to ask you first is come over here to the side. How would I factor that? It's a difference of two squares. Yeah, these are the ones that are really easy. You take the square root of both terms, one factor's plus, one factor's minus. So x plus 1, x minus 1. How would I factor this? Would it be identical? Yeah, it'd be opposite. So it would be 1 plus x, 1 minus x. Now, x plus 1 and 1 plus x, those are the same thing. But these are not the same, right? When you subtract, it's not commutative. Okay, so look at this and how we factored it, and look at this numerator. Do you see that it's the same kind of problem? I have 1 minus something being squared. So I'm going to factor that just like I factored this. So the factors would be 1 plus sine x and 1 minus sine x over 1 plus sine x. Do you see how these factors are just like these? It's not just an x, it's a sine of x, but the process of factoring is the same. Okay, now look what I have. Amazing! I have a 1 plus sine x and a 1 plus sine x. It is a factor. It is being multiplied by something. So those do reduce. And I just have 1 minus sine x left. That is one trig function, which is what we were asked to do. Simplify until we just had one trig function. Am I good with that? Okay, example 17. Factor x squared minus 2x plus 1. Okay, so there's not a trig function in this. Should be easy, right? not a trick. I want you to factor that. We've factored. Factor that. You know the method you like by now, I hope. Find those factors for me. I see lots of good answers. Does anybody want to share what they got? Somebody? Go ahead. Two identical factors, right? Did anybody write that as x minus 1 squared? You don't have to, but you could. Right, because I have two identical factors. Okay? Alright, so how would I factor this? Do you see that it's the same problem? It's identical. Something is squared. Sine is squared. Minus 2 times something, minus 2 times sine, plus 1. Okay, so it's a trinomial. I don't have a greatest common factor, so there's nothing to factor out. So I'm going to figure out what two things would multiply to give me this. Okay, start with the first term. What two things do you multiply to get sine squared? Sine times sine, right? Sine times sine is sine squared. Now, go to the back end of it, the number. What two things do you multiply to get 1? Yeah, you have no choice there, 1 and 1. Okay, now, think about your sines, your SIGNs. What do they need to be so that when I distribute, I get negative 2 sine in the middle? They both need to be a negative. Okay, if you're not sure if it's right, FOIL it out, distribute, and you'll know. Okay, so those are my factors. Question on that? Okay, so we're going to be factoring things today, sometimes that have sinusoids in them. All right, let's look at 18. Factor sine x minus cosine squared x minus 1. Okay, I don't like that one because I have a sine and cosine. Like, that's a mixture of two different trig functions, whereas this one only had one trig function, so it was easier. Any ideas how I can get it to represent only one trig function? Hence, Pythagorean identities. Okay, so look at this first identity. Sine squared plus cosine squared is 1. I'm going to write it over here. Sine squared plus cosine squared is 1. That's that main Pythagorean identity that we've used. Okay, how can this help me? Okay, so what if I did this? What if I subtracted cosine for both sides? Then I would have 1 minus cosine squared, but that's not exactly what I have, is it? But what if I solved it for cosine squared and then subbed it in? That's what I'm going to try. Okay, so if I solve this for cosine squared, I would have cosine squared equals 1 minus sine squared. Is everybody okay with that? Okay, now I'm going to take this right here and sub it in for that. If cosine squared equals that, then I can replace cosine squared with that. Okay, so what this becomes is sine x minus, put this stuff in its place, minus 1. I'm going to distribute a negative 1 basically here. So I will have sine x minus 1 plus sine squared minus 1. Okay, I didn't get rid of anything, but I don't see any cosines there anymore. So I'm going to put this in descending order. I'm going to put the sine squared first, then I'm going to put the sine, then minus 2. Okay, can we factor this? Set up your two factors, because I don't have a greatest common factor. Okay, what two things do I multiply together to get sine squared? Sine times sine. What two things do I multiply to get 2? 2 and 1. Okay, if this is a negative 2, one of these has to be plus and one has to be minus, right? Okay, which one goes where? Plus here, minus here. Someone explain how you got that. Okay? Okay. Okay, you're looking at that middle term, which is positive sine. I have 2 sine and negative 1 sine, and if I add those together, that gives me the positive 1. What if I switch those? Would it matter? Yes, it would make this middle term be a negative sign. Okay? All right, so that would be factored. Question. Okay, let's solve some equations. All right, example 19. Solve the equation, and this goes for all of these next few examples that I'm doing. Solve the equation on the interval 0 to 2 pi. Okay. What does that mean? On the interval 0 to 2 pi. Basically means, yeah, go all the way around the circle and look for answers. So I'm not just limiting it to certain quadrants. I'm telling you, we're going to look at the whole circle. Okay, so we're going to start at 0. We're going to rotate all the way around to 2 pi, looking for any answers that satisfy our equation. Okay, first one. 2 sine squared theta equals 1. Not 100% sure just by looking at that, right? How would you solve this equation? Divide by 2 and then square root. Okay, so I would get x squared equals 1/2. But when I square root, what is that little thing I need to remember? Plus or minus. Okay, so I would have x equals plus or minus the square root of 1/2. Okay, square root of 1/2 is also the square root of 1 over the square root of 2. Okay, but what's the square root of 1? 1. Okay, 1 over square root of 2 can be rationalized to be Square root of 2 over 2. Ooh, that number looks familiar, doesn't it? Okay, so this is what I'm going to do over here. I'm going to divide by 2. And I'm going to get sine squared theta equals 1/2. And I don't want to know what sine squared is. I want to know what sine is. So I'm going to square root. Plus or minus square root. Square and square root are inverses. So that just gives me sine. Plus or minus square root 1 over square root 2, which is plus or minus 1 over square root 2. But when I rationalize it, I get plus or minus square root 2 over 2. Now, I know what those are. Those look familiar. Notice I went positive or negative. So I want to know where sine is positive or negative square root of 2 over 2. Okay, on my unit circle, where do I find sine values? The y-coordinates. So I'm going to look from 0 to 2 pi anywhere that I see positive or negative square root of 2 over 2 for the y-coordinate. Okay, I'm traveling through the first quadrant. I see it at pi over 4. Now notice I gave you the domain in radians. That means I want my answer in radians. Okay, so theta will equal pi over 4. Okay, traveling to the second quadrant, what do I find? 3 pi over 4. Traveling to the third quadrant, what do I find? 5 pi over 4. And what about the fourth quadrant? 7 pi over 4. So I'm pulling out every single angle that meets that description. So I actually have 4 answers to this equation. Question? All right, I've got 3 more we're going to get through here. Okay, sine x, tangent squared x equals sine x. Should I start this one? What if I had xy squared equals x? Okay, I can't divide by a variable, otherwise I get rid of an answer. So I don't want to divide by sine x, otherwise I'm getting rid of a solution. But I can subtract that over and set it equal to 0. Why would I possibly want a 0 over there? Yeah, remember when we factor, we want that 0 on the right so that we can set the factors equal to 0. Okay, so those are not like terms. They don't combine. But what do you notice is common to both of these terms? Sine x. I'm going to factor that out. Like that. Okay, now remember that lovely zero product property that says if 2 things are multiplied and their product is 0, at least one of them has to be 0. Okay, so that's what I'm going to do. I'm going to say, okay, here's one thing. Either that is 0 or this is 0. Okay, well, I could find that pretty easily on my unit circle. I'm going to look on the whole unit circle, see where sine of something is 0. Let's go ahead and do that before we tackle this one. Where is sine 0? 0 and pi. Sine is the y-coordinate. I see y-coordinates at 0 and pi. Oops, that should be an x. Okay, now let's talk about this. Let's add 1. And then square root. But don't forget your plus or minus. What's the square root of 1 again? 1. Tangent x equals positive or negative 1. Okay, so I'm looking for where tangent is positive or negative 1. Remember, tangent is y over x. The only way that fraction is going to equal 1 is if y and x are the same thing. Right? Okay? Right there. What's tangent there? 1. What's tangent over here? Negative 1. What's tangent here? Positive 1, because it's negative over negative. What's tangent here? Negative 1. So all 4 of those fit this description. So I'm going to add to my answers pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So this one has 6 answers. Anything that fits those descriptions will be my answer. Question? Alrighty, two more. Cosine cubed over sine equals cotangent. That's got 3 trig functions, a cosine, a sine, and a cotangent. What do you think we should do? Maybe turn things into sine and cosine? Okay, so cotangent would become what? Cosine over sine. Okay. What if I multiplied both sides by sine? What would happen? Okay. So what's left is cosine cubed equals cosine. Now, I could maybe look on the unit circle and see where that's true, but that's kind of hard to imagine where cubing cosine will give me the same thing as cosine. I don't know. What do you think? Can we figure that out? What is cosine on the unit circle? The x. You think we could figure that out? Think, what kind of number could you cube and get that same number? 1? I can think of 2 more. What? What kind of number could you cube and get that same number? 1 is one of them. Negative 1 and 0. Doesn't that make sense? So that's really all we have to find. Where's cosine 0? Where's cosine 1? And where's cosine negative 1? Now I'll show you how we would solve it without realizing that. But let's find those answers first. So remember, cosine is your x coordinate. So where's cosine 0? At pi over 2 and 3 pi over 2. Okay, where is cosine 1 and negative 1? It's 1 over here, and it's negative 1 over here. So we'll add to that 0 and pi. Oh, you know what? If I included 2 pi, I'd actually have to say 2 pi also. If I had parentheses at 2 pi, I wouldn't. But if I had brackets at 2 pi, I would. Okay, so what if we didn't recognize that, or what if it was not a number that was just easy to figure out like that? What I would do is I would subtract cosine, and set it equal to 0 and factor out a cosine. Like that. And then I would just want to know, okay, where's cosine 0? Or, where's cosine squared x minus 1 equal to 0? Add 1. Square root, plus or minus, square root. So where's cosine positive or negative 1? So we're still ending up with those same values that we knew to look for. Okay, so that's how I would solve it algebraically. Alrighty, one more. Two sine squared y plus sine y equals 1. What do you think we should do? What did you say? Subtract 1, absolutely. I want it equal to 0 because then what will I try to do? Factor. Okay? Alright, is there a greatest common factor? Nope. So let's set up our parentheses. And usually these are not terribly tricky to factor. Usually they're pretty basic numbers. How do I get 2 sine squared? Okay, one of them is a 2, right? So I have a 2 sine and a 1 sine. If I multiply those together, I get 2 sine squared. Go to the back number. How do you get 1? 1 times 1. Only option. Okay, so now I want to figure out the SIGNs. Plus minus goes where so that I get positive 1 sine in the middle. Does it matter? Okay, so what if I had plus here, minus here? Does it work? Because when I distribute, when I FOIL, that's negative 2 sine, and that's positive 1 sine. So what do I get in the middle? Negative 1. Okay, so it does matter. So let's fix it. We know it's not what we just tried, so it must be the opposite. So I'm going to need plus there, minus there. Okay, so distribute, FOIL. Positive 2 sine, negative 1 sine gives me positive 1 sine in the middle. Okay, so once I have those two factors, I'm going to say, all right, this equals 0 or this equals 0. That's the only way I get a product of 0. Okay, get sine y by itself. What would you do? 2 steps. Add 1 and divide by 2. So I get 2 sine y equals 1. Sine y equals 1/2. Okay, that one is ready to go to the unit circle and look for where that happens. Over here, get sine y by itself. Well, what do I have? Sine y equals negative 1. Whew, didn't have to square root either of these. Okay, so I'm going to go to the unit circle and I'm going to figure out where is sine 1/2, where is sine negative 1. Those will be my answers. Okay, so y, which is representing the angle here, sine is 1/2 at pi over 6 and 5 pi over 6. And sine is negative 1 only at 3 pi over 2. Bless you. So that one had 3 answers. Questions? All right. So you have 1, 2, 3, 4, like 9 of these or so to try. Okay? Now, if you get to the point where you are pulling out your hair and crying, move on to the next one. Okay? Just because they have a higher number doesn't mean they will be harder, so give them all a good effort. Move on if you are getting to the point where you're about to lose your mind. Look at your notes, because I chose these problems because they will be represented on your homework. Okay? And then if you want to, while you're sitting around watching TV tonight, check out those review problems. Sounds like a good night, doesn't it?